Imagine a carpenter in Catway trying to show a customer a design for a new wooden bench. If the drawing only shows a flat rectangle representing the front face, the customer has no way of knowing how deep or wide the bench actually is. To clearly communicate the final product, the drawing needs to show length, width, and height all at the same time. This is a pictorial drawing, a method used to make a flat piece of paper look like a three-dimensional object. You only need specific drafting tools to make this happen. The most critical are your set squares, the 30/60 degree and 45 degree triangles. By using the fixed angles of these tools against a horizontal baseline, you can construct a three-dimensional shape mathematically. It is the exact process engineers, architects, and designers use to map out a physical structure before any material is cut. We start with isometric projection. In an isometric drawing, you are always looking directly at one of the object's front corners. Therefore, the very first step is drawing a single vertical line up from your base reference line. From the bottom of that vertical corner, the horizontal edges of the real object are drawn slanting upward. You trace these receding lines to the left and right using your 30-degree set square. In isometric projection, there are no completely flat horizontal lines. Real objects often have angled cuts or slopes, which are difficult to plot in empty space. Instead, you build a faint bounding box, or a crate, using only vertical and 30-degree lines. This establishes the absolute maximum length, width, and height of your object. Once the crate is built, you carve out the final shape. If a block has a slanted side, you measure down the outer edges of the crate to find your start and end points, and then simply draw a straight line between them. Pause the video here. Using this faint crate on your screen, practice sketching out the dark lines to create a step cut that drops exactly 20 millimeters from the top right corner. The crating method gives you a reliable framework. By measuring along the straight axes first, you ensure any slants or complex physical features inside the block stay completely proportional. This diagram highlights a major limitation of isometric drawing. If you draw an object like an energy-saving stove, the circular opening on the front face stretches out into a distorted oval, or ellipse, which is highly difficult to draw precisely. We use oblique projection to bypass this problem. In oblique drawing, you turn the object so its primary front face rests perfectly flat against the paper. This allows you to draw circles and complex curves exactly as they look in real life, using a standard compass. To give this flat face 3 dimensions, you draw the sidelines pushing backward. For oblique projection, you swap tools and use your 45-degree set square to map out the depth. If you draw those depth lines to their actual true length, a method called cavalier oblique, the overall object appears unnaturally stretched. To fix this optical illusion and make the drawing look realistic, we use cabinet oblique, where we cut those depth lines exactly in half. Drafting an object in oblique cabinet projection rather than isometric is a deliberate calculation. You make this choice anytime your object contains complicated circles or details focused strictly on its front face. Looking at both methods side by side on a structure like a wooden kiosk shows exactly how the tools dictate the final shape on the page. The isometric view starts at the corner, with both sides pulling back at 30 degrees. The oblique view starts flat on the front face, with the single visible side pushing back at 45 degrees. As a working rule, choose isometric projection when the object features complex geometry on multiple sides. Choose oblique projection when the complexity is contained to a single flat front face. This table summarizes the rules, angles, and specific circle behaviors for both methods. Pause the video and record these specifications in your notes. Before concrete is poured or steel is bolted together, these geometric principles are applied to paper. Mastering these set squares and angles allows you to take abstract measurements and map them into a precise physical reality.